So in example number 19, remember in example 18, we had the car that was turning due to the friction. So an engineer proposes that it's possible to create a curve, same curve, so we still want the radius there to be equal to 250, right? Same curve, but the car is now going to bank without friction. No friction is going to be needed. So if we now look at the situation, we say, okay, well, let's go ahead and do our free body diagram. So we've got the force of gravity down, and then we have the normal force, which is kind of up like that, right? Now, the normal force, remember, has to be perpendicular to the surface. That's why it's kind of going up and to the left there. Now, if there's no friction, then the car shouldn't be sliding up or down. It just stays at that height going around the curve just like that. Now, at this point, we can look and say, okay, well, what is the centripetal force? Well, the centripetal force has to be pointing towards the center of the circle. Now, gravity certainly is not doing that. If you notice, it's actually the horizontal component of the normal force that is pushing towards the center of the circle. The vertical part of the normal force has to oppose gravity there. But then the horizontal is going to be what's pushing to the middle, allowing the car to turn. So this time, what is the centripetal force? Well, we're going to say that the normal force's x component is the centripetal force. All right. Now, we're going to need to figure out what both of those are. Now, this time it does say at what angle should it be banked. So we have the speed here, 25 meters per second. So we know that the centripetal force here, we're going to change into mv squared over r, just like that. And we have the speed there. We don't have the mass, but remember last time the mass canceled out. We've got the r, same curve as before. So now we just need to deal with this normal force, the horizontal component. Well, if you think about it, we can already say that the vertical component of the normal force is equal to the force of gravity. So if I kind of come over here, let's redraw that normal force here, right? I know that the vertical component of the normal force is going to be equal to mg, right? And then I need this right here. This is going to be that horizontal component, all right? Of course, the angle that we're dealing with is this one right here. Remember, the angle is how far up that ramp has been rotated. So that's how far over our normal force has been rotated, because it's normally straight up. Now, can we connect our angle to the side that we have, to that mg? And the answer is yes, we can, right? We can say that tangent of theta is equal to the opposite side, that's what we wanted, the normal force of x, over the adjacent side, mg. Or in other words, mg tangent theta is equal to that x, which is the normal force x component, just like that. And so we can go ahead and we'll put this in for the normal force there. So we go mg tangent theta. Now, at this point, of course, we recognize that the masses are going to cancel out, and we can start putting some numbers in, right? We know that the velocity they want us to use is 25. We know that the radius is 250. I got g over there, which is 9.8, and then tangent of theta. And so we're going to do the 25 squared, which is 625. Divide that by the 250, and then we're going to divide by the 9.8 on the other side, which is going to give us that tangent of theta needs to be equal to 0.255. And now we can do the inverse tangent of both sides, and we get about 14 degrees. 14.3 is what I got here. I guess I only have two significant figures up there, so I'm going to leave it as 14 degrees. There we go. We found the angle. Now, again, you may not have recognized that that's what we needed to do from the beginning. What we do is we say, okay, I see there's a circle. Because there's a circle, I'm going to find out what the centripetal force is. We drew our free body diagram. The only force going in the direction, that horizontal direction towards the middle of the circle, was the normal force in the x component. And then from there, we were able to connect the angle to the normal force by balancing the vertical forces there with the force of gravity. All right? So one step at a time. We don't know where this is going to go from the beginning very often, but going step by step, we can make the connections that we need to make. All right?